आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In today's episode of our podcast, we have Professor Sudipto Saha, Associate Professor in the Department of Biological Sciences in Bose Institute. He shares about his vast experience in the field of research.
My name is Sudipto Saha, Associate Professor at the Department of Biological Science, Bose Institute. I have a research experience in bioinformatics and artificial intelligence in the human health care for about 20 years. I did my bachelor's and master's in microbiology and PhD in bioinformatics from CSR IMTech, which is Institute of Microbial Technology, Chandigarh in 2007. I did 2 postdocs for 5 years from 2007 to 2012 at Indiana University and Case Western Reserve University, USA. I joined Bose Institute as a DBT Re-entry Ramalingasamy Fellow in 2012. Recently in 2023, I published a book on pulmonomics, which is the omics approaches in understanding pulmonomics.
Professor Saha talks about the importance of data science and artificial intelligence in improving respiratory health care.
So today I am going to talk in the area of data science and artificial intelligence to improve the respiratory health care. So the research goal of my lab is to identify biomarkers and drug targets for diagnosis and treatment of lung diseases like obstructive pulmonary disease like asthma, COPD, and multi-drug resistance tuberculosis. So we develop biological databases and prediction models based on machine learning tools for the benefit of the scientific community as well as the common man as an end users. We also validate some of our in silico analysis in the wet lab experiments in the mice model.
Sir highlights the wide implication of such research in human life.
So in the post-COVID era, respiratory diseases are getting attention, and so my lab is focused on studying the lung diseases by compiling and manually curating the omics data, generally genomics, transcriptomics, proteomics, which are available in the public domain. So here I'll talk about two online applications developed in my lab. First is the application of lung healthcare. So we developed a web application which is called LHS Spread, which stands for Lung Health Severity Prediction, which is based on the mathematical model based on machine learning tool. The models was trained using lung CT scan data and with 6 blood parameters. Generally for checking lung health, we use X-rays or CT scans. For routine checkup, like after post-COVID era, these tools are not recommended as frequent exposure to X-rays is not good for health and may lead to cancer. On the other hand, the CT scans, which is generally mostly used, they're very costly and they charge approximately 6,000 to 10,000 Indian rupees per visit. So for this, we developed a web tool which is called LHS Spread for predicting the lung health severity based on only 6 blood parameters, namely white blood cell count, neutrophil to lymphocyte ratio, aspartate aminotransferase, albumin, lactate dehydrogenase, and C-reactive protein. These blood tests cost only 1,500 rupees, and these values can be used in the application LHS Spread, and it predicts the lung health severity in a very user-friendly manner so that the common man can use it even in a mobile having an internet access. So it is freely available in a Bose Institute. And another application I like to talk about, which is called the multiple drug resistance tuberculosis. Tuberculosis, as you know, is a major respiratory disease and is India's major health problem. The end TB strategy was developed by World Health Assembly to end TB by 2023, whereas our Indian government took an initiative to end TB by 2025. The greatest challenge of NTB and the multi-drug resistance are the multi-drug resistance and extensive drug resistant tuberculosis. According to the WHO 2022 report, there are 4% new cases of MTB. And also the patients which are already in the drug regimen, 21% get MDR-TB. So you can understand the rate of MDR-TB in a whole world. So for this, we developed a web tool called MCDR-MTB that can predict the drug resistance MTB and classify them into multiple drug resistance, extensively drug resistant, or susceptible one. The drug regimens for susceptible and MDR resistance MTB are different. So once we know the type of clinical MTB strains a person is infected with, accordingly drugs can be given. So I believe this web tool can be useful to the common man. The only issue here is that the need for next generation sequencing machine to generate the whole genome sequencing data of the clinical MTB clinical isolate. However, nowadays the sequencing technology is very cheaper and the tool which we developed is available in the Bose Institute web server.
Sir speaks about the possible future direction for his present research.
So in the first case, I was talking about the lung health severity prediction server. So it needs internet access. But for in the remote places where there is no internet, we are thinking of making it as a mobile app so that in remote places wherever there is no internet, still people can use it. And for the second case, where I was talking about the drug resistance MTB diagnosis, so the model which was developed, it was based on 16 drug resistant genes, which comprise about 6,080 mutations. So the input was, we have to do it genome sequencing, and you have to give input of 16 drug resistance of coming from 6,080 mutations. So we thought of developing a minimalistic model, having a minimum feature. So we observed that our minimalistic model of 5 mutations, only 5 mutations, and coming from only 4 genes, can predict the drug resistance TB into multi-drug resistance, extended drug resistance, and susceptible with an accuracy of 90%. So it's very accurate. Even if we can use only the 5 mutations coming from the 4 genes, we can classify the TB into drug resistance, extremely drug resistant, and susceptible one. Based on our findings, we propose a DNA strip-based technology that uses 5 gene mutations for laboratory-based testing, and it can predict the susceptibility.
Professor explains in detail about the DNA strip-based technology.
In the DNA strip-based technology, we take the DNA from the sputum of patients, and then those DNA should be coming from the MTB, which is microbacterial tuberculosis, and we amplify the DNA and for specific gene mutations. And we try to detect those specific gene mutations. In my case, I was talking about the 5 mutations coming from 4 genes, and based on the hybridization-based technology, we identify or detect those 5 mutations. So in this work plan, whole genome sequencing is not required at all. And currently, laboratory-based MTB drug susceptibility takes about 4 to 6 weeks. Whereas our proposed method, it will take only 5 hours time.
Professor Saha gives us an idea about India's position in the research field of translational bioinformatics. He also talks about the various collaborations that help in this research.
I think in the translational bioinformatics research area, I think we rank around 2 to 5% in India. So for the drug disease MTB research work, similar work is carried out in ICMR, National Institute of Research in Tuberculosis, Chennai. So we are thinking of collaborating with them, and we can implement the DNA strip technology at a clinical level at NIRT Chennai.
Sir explains about the process of gene sequencing.
Okay, so in India, Government of India, mainly the DBT, DST, in most of the institutes, the machine is available where you can get the work done, and the price varies from whether you do it in a government institute. It costs around 10,000 rupees for each MTB clinical assembly data. But if you do it in a number of samples, it increases from 1 to 100, then the price may get lower.
Professor speaks about his expectations of industry-academia collaboration in his research area.
So, frankly speaking, I'm looking forward to the Indian industry-academia collaboration so that the DNA strip technology, what we are planning to, we can implement it. So right now, I didn't find any Indian industry which works in the DNA strip technology.
We thank Professor Saha for invaluable insights.